So, if you've been paying attention to AI lately, you've probably heard this massive promise. Just put multiple AI agents in a room together and they'll solve all our problems. But what if they don't? Welcome to this explainer. Today, we're going to dive deep into the systems engineering behind multi-agent AI verification. Now, on the surface, deploying a bunch of agents to work together sounds like an incredibly robust solution, but we're going to take a calm, methodical approach today to unpack exactly how these systems are built, where they draw their inspiration from, and uncover a fundamental flaw that could actually be scaling up mistakes rather than discovering the truth.
Okay, let's jump right into our agenda. We'll be looking at the multi-agent verification flow, the illusion of independence, correlated failure, the danger of consensus, testing with structural constraints, and finally, the true purpose of redundancy. Starting things off with Section 1, multi-agent verification flow, and how systems like Apodex actually scale up problem solving. Now, what AI is doing here is taking one of the oldest tricks in the traditional computing playbook, redundancy, and completely shifting it from physical hardware to parallel reasoning. Think about it. Normally, if a physical machine might fail, we just add another one, right? If a hard drive might crash, we back it up. Well, systems like Apodex are taking that exact same foundational idea and applying it to AI verification. Instead of betting everything on a single agent to solve a really complex problem, we deploy multiple agents in parallel. They all generate candidate answers and then hand them over to a global judge. Let's walk through how this actually builds into a globally judged final output. A single problem enters the system, and several different agents, we'll call them A, B, C, and D, get to work on it completely in parallel. They churn out multiple candidate answers. Then, our global agent steps in, compares all the options, and decides which one is the most accurate. Boom, one final verified answer emerges. And theoretically, this is a massive upgrade over a single agent. Maybe one agent catches a tiny piece of evidence the others missed, or flags a critical error that slipped right by the rest. To pick that absolute best answer, the global judge meticulously grades these outputs across some really strict criteria. It looks at evidence quality, like did the agent notice missing or really strong data? It checks for reasoning consistency, making sure the logical path is completely sound and unbroken from start to finish. And of course, it scans for contradictions, looking for any exposed disagreements or just plain weak logic. Honestly, it sounds like an absolutely airtight system for generating reliable truth, right? Well, actually, not quite. Which brings us to Section 2, the illusion of independence and what we call the physical sensor analogy.
So, here is the absolutely crucial point we need to understand. Redundancy only works when failures are sufficiently independent, period. If they aren't independent, you're not actually increasing reliability at all. You are literally just turning up the volume on the exact same output.
To put that into perspective, imagine you have 3 physical sensors measuring the exact same temperature. If one fails randomly, your other 2 independent sensors are going to catch the error, right? That is true redundancy. But what if all 3 sensors were built on the same manufacturing line, using the exact same defective component? Now, all 3 are going to give you the exact same wrong reading. You've increased the number of sensors, sure, but your reliability hasn't improved one bit.
And that leads us perfectly into Section 3, understanding correlated failure, which is the hidden foundation of these AI agents.
So what does this actually mean? Correlated failure happens when systems agree on a wrong answer because the exact same underlying tendencies are pushing all of them toward the exact same false conclusion. The agents might use slightly different wording, but they're agreeing not because they found the truth, but because they share identical flawed assumptions. It's kind of like asking 3 random people for directions, only to find out they all secretly use the exact same broken GPS.
See, you might have several agents that look totally separate on the surface. It might even be labeled Agent A, B, and C. But underneath, they are inextricably linked to a hidden foundation. They often share the same base model, they share the same training data, the same architecture, the same reward system, and because of that, they inevitably share the exact same blind spots. The real central problem with multi-agent verification is that we aren't actually dealing with truly independent minds.
Now let's move on to Section 4, the danger of consensus, and how we end up with a massive hierarchy of unverified opinions. This right here is the terrifying loop of recursive self-improvement. Our global agent doesn't actually eliminate correlated failure, it just adds another layer of judgment on top of it. And guess what? That judge might share the exact same weaknesses as the agents it's evaluating.
If the global agent simply prefers, say, the clearest structure or the most familiar patterns, it's going to choose a wrong but highly polished answer. Then, that accepted mistake becomes new training data. The next generation learns from that approved mistake. It's no longer seen as an error. It literally becomes the system standard. So while redundancy might reduce local random mistakes, it entirely preserves systemic drift.
I really want you to think about this statement. 100 copies of the same model do not create 100 independent minds. When dependent agents reach a consensus, they are really just scaling the exact same error 100 times over. Because they all agree, the system risks replacing a single unverified opinion with this massive structural hierarchy of unverified opinions. And the scary part? The mere appearance of internal debate makes the final result feel way more trustworthy than it actually is.
All right, let's look at a solution in Section 5, testing with structural constraints, and specifically the energetic paradigms approach. To make absolutely sure an answer isn't just a beautifully polished hallucination, a structurally controlled system has to ask tough questions. Like, does the answer remain consistent across different evidence sources? The system literally needs to hunt for the exact evidence that would disprove the answer it just came up with. We also have to demand to know, does it preserve causal coherence? Does the logic actually hold together out in the real world? We have to see if the generated answer stays stable when the foundational assumptions change, or if the whole thing just completely falls apart. Furthermore, does it respect resource, cost, and time constraints? Does the answer maybe hide a massive trade-off by just moving the cost somewhere else? An AI can easily spit out a brilliant-sounding solution that works perfectly in a vacuum but completely ignores actual, real-world limitations. Finally, we always have to ask, can the decision be reversed before the error gets permanently embedded in later stages? Can we realistically undo a mistake before it becomes a permanent part of the system's baseline? Asking these structurally constraining questions makes the verification process vastly stronger than just relying on a simple multi-agent vote. Which brings us to our final part, Section 6, the true purpose of redundancy. It's about exposing uncertainty, not manufacturing truth. You see, reliability doesn't just magically appear by increasing quality. It comes from the really complex relationship between diversity, independence, constraints, evidence, and correction. When AI agents disagree, the system shouldn't just immediately force a winner so it can spit out a final answer. That disagreement is actually incredibly valuable information. It might highlight missing evidence or unstable assumptions or a problem that just simply cannot be resolved yet. A properly designed system holds on to that uncertainty until real evidence or testing can reduce it. Having more agents definitely improves coverage, but it absolutely does not automatically create truth.
To wrap this up, remember this. More agents create more opportunities to detect error. They do not automatically create truth. Redundancy without structural verification is just repetition, and repetition without independence, that's not truth. Multi-agent consensus, if it's missing these vital conditions, can easily just become a machine for scaling the exact same mistake. So we really need to ask ourselves, are we building systems that actually discover truth, or are we just building machines that confidently scale errors? Thanks for joining me for this explainer.